All right, good evening all. You are welcome to Tutorials with From Eternity the Schoolboy. Today we take a look at physics. In our last class, remember we are still treating measurement and units. And in our last class we treated the measurement of volume, where we discussed a lot of things there, starting from the measurement of volume of solid, regular solid, and what irregular what solid. Then we went to measurement of what volume of liquids. Good. So in today's class, we just move straight to what? Weight, mass, and what? Weight, mass, and what? Weight. Measurement of mass and what? Weight. Who can define the term of, let me ask a question. Weight and mass, are they the same thing? Weight and mass, are they the same thing? Okay, who can differentiate between weight and mass for us? Who can differentiate between weight and mass for us? What is the difference between weight and mass? Who can do that? Who can do that? Nobody. Are you serious? Are you for real? Stephen, save us. And what is the difference between weight and mass? Are they the same thing? So why are they, what makes them not to be the same thing? Who? Are you raising your hand? Oh yeah, tell us.
So I can't remember something. I don't know if I can still recall that mass, we're talking about space occupied by an object, or then weight is all about capacity of an object.
Any other person? Tell us. Fast. The difference between weight and mass.
Mass is a fundamental quantity, and weight is a derived quantity.
I agree with you. Yes. He said that, but the point is correct. He said that mass is a fundamental quantity, and weight is a derived quantity. I agree. What other difference? But that is not the major difference.
Mass is a weight of a body.
Mass is weight of a body. What are you saying?
No. Okay. Weight is the pull of gravity.
Pull of gravity.
And mass is the
what?
Is the
Stephen want to try. So what's going on? You don't say anything. Even you. Our star girl say, "I keep it quiet." Mass is what? Mass is how much mass? What are you saying?
Sorry. Mass is how much matter a body contains. Why this weight is a gravitational force.
I like that. Mass is the quantity of what? Matter. Am I communicating? Are we together? Mass is the quantity of matter a body what? Contains. Okay? The quantity of matter now inside you as a human being is your what? Mass. So mass is the quantity of what? Matter that make up a what? A body or a substance, as the case may be. The quantity of what? Matter that make up a what? A body. See.
As if you come and never explain.
Is that what?
I thought you were explaining, sir. I don't even like that.
Okay. I say that mass is the quantity of matter that make up a body. Are you sure you are not decided by that thing, I mean? Are you sure? You are listening? Okay. Okay. Mass is the quantity of what? Matter that make up a body or a body contains. Okay. Good. But weight is what? What do you say about weight?
It's a gravitational force.
Pull on the what? On the body, right? Good. The gravitational force or the pull on the what? The body. Gravitational force or pull on the what? The body. So, mass is the quantity of matter. Weight is a force. Mass is quantity, right? Weight is what? Force. True of force is force. So that's why it's people say that mass. Okay, let's come down first. Let's go to their unit. Mass is measured in what? It is measured in what? SI is what? What is the SI unit of mass? kg. You're not sure. Have confidence. You're saying kg. Be good. Kilogram. The unit of mass is what? Kilogram. Why the unit of weight is what? Newton. True of us. That's why a institutional now say that mass is a fundamental quantity. Why weight is a what? Derived quantity. That's why I agree with him with my full chest. Then another important difference between the two of them is that mass is constant everywhere. Your mass now is constant everywhere. The mass of this thing now is constant everywhere. But weight is what? Weight varies. Do you know why weight varies? Who can tell me why weight varies? There's something you're missing. Acceleration due to gravity is also what? Acceleration due to what? Gravity varies. That's why weight. You know that weight, remember I told you that weight is actually what? Mass times what? G. Okay? Weight is what? Mass times what? We'll see through this as a topic, but I just want to show you why weight varies. This is what is called acceleration due to what? It's not the same thing in different parts of the it's not the same thing. It varies. Okay? It varies in different places, dg. So because it varies in different places, if you use it to multiply m, that means weight to do what? Vary. True of us, the weight will now vary. That's why the weight varies. But the mass is what? Constant. It doesn't, your mass here is something elsewhere. Your mass will not change because you travel to one part of the world or one whatever. It's something. That's your mass. But weight may vary depending on the acceleration. Are you aware that there are some places you will go? If you jump up, you remain in the air. Are you aware? You not seen that before. You must not see it now, but it exists. That's why you're here. We're here to teach you. So you learn. It exists, okay? As you hear that, you know why that you cannot just jump up and remain there. Because the pool here will do what? Pull you down. But at the place you go, you may jump. People are float. You can float. The G is not the same thing everywhere, okay? Browse it, you're not serious. Browse it. When I need information, I need information with that mind. Let me do it. Okay?
Does it only happen in space?
Yeah?
Does it only happen in space?
In space. Whether it's happening in space.
Does it only happen in space?
Only.
Happens in space.
In space. Once you live here now and jump up, are you not in space?
No, we can't handle it.
I'm telling you now, I'm informing you now.
But space, they don't like they float from the air.
Okay, let me understand what you mean by space. Altitude.
Yes.
I'm telling you, even as you just be floating, you can't even it's not that altitude though. Normal is you floating, you can float. You float. I've seen it not just by book, by physics. I've seen it. I've watched it on telly. I've seen it. It's not magic. It's not a long story. It's not theory. Huh? Oh, is that what you have? All right, let's continue. Okay, so G does what? Varies. That's why the weight is not what? Constant. Okay? That's why the weight does what? Vary. Okay, now, in terms of what you use to measure them, weight is measured using what? Using what? Using what? Newton. What are you saying? I say measured using which device or instrument? Huh? Spring balance. You use spring balance for what? Weight. What do you use for mass? Huh? Weighing balance. I like that. Chemical balance is there. I like that. Chemical balance. Now, listen carefully. What's that?
Mass uses what?
Mass. Use chemical balance. Chemical balance, yes. Use chemical balance, but weight, use what? Spring what? Balance. Chemical balance. Gift. Where are you going to? You are going, you say you are coming back, you are going. Calling me what they're saying. You say what? Okay. Now, chemical balance, we have what? Spring balance. There's something I want to let you know about this too. This chemical balance, we also have beam balance too. Am I communicating? Yeah. Beam balance. This balance for mass operates on the principles of the moment. You know moment now, right? Moment is when you have you do it when you are small, when you are a child, but you may not know what you are doing. You will sit here. Your friend will sit. You put a plank here, and you put a stone here. Your friend will sit here. You say what? Jangle, okay? Anyway, your friend will sit here, and you sit here, and your friend will if your friend has the amount of your friend is very, your friend will just put you be hanging on the air. It will go like this. So this is what moment is all about. We see treat moment as a what? Topic, okay? Now, this operates on the what? Principle of what? Moments. But spring balance, chemical balance, beam balance, blah, 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 they operate on the principle of what? Moments. But spring balance operates based on what? Hooke's law. Hooke's law. Who knows about Hooke's law here? Hooke's law. Hooke's law. Don't worry, we'll see treat it. Hooke's law. Operate on what? Hooke's law. We say that the applied force is directly proportional to the what? If you have a spring, remember from the name spring, okay? Spring what? Balance. If you have a spring and if you stretch it, the more you stretch it, the more you apply force on it, the more it stretches. That means it will extend, right? But provided that the elastic limit is not what? Exceeded. It will still be, as you're applying a force, drawing it's what? Extending. Okay? So the spring balance is based on what? Hooke's law. But this one is based on what? Principle of what? Of moment. Now for spring balance, now if you have spring balance can look like this. You have something like it has two parts. We have a part. We have three parts. You have a scale. This is the scale, and inside the scale now is calibrated. is calibrated. Inside it, maybe it's calibrated. Inside it, there is a spring, okay, that extends here. Then there's what you can use to hang it on the either on a fixed position. It's not good to use it, hold it while it should be hanged. Now, if you attach a weight here, a body here, it's now acting under what? Gravity, right? It's pulling. So as it's going down, the spring, it will read this on the scale. Wherever it stops here, shows you the weight of the watch, not the mass now. It shows you what? The weight of the watch, the body you put here, you fixed here. Am I complicating? That one, you say what? That one is easy to do. Once just hang it, attach the weight, the body here, and look at it. It just be going down until it becomes what? Steady. That is the weight of the what? The body. That is how to use what? The spring what? Balance. But the main thing is that you should not hold it. You should what? Just hang it in a fixed what? Position. So it doesn't affect what you are reading. Now that is how you can use what? Spring what? Balance. So here you have the point. The pointer will be moving on this scale. Wherever it stops, you read the what? The weights of the body. Now, I want us to know something. Let's look at the balance, the chemical beam balance for mass. Now, I don't know the type of lab you had in your secondary school. Okay. Those that are in school here, you still do practical with the one we have here. But those that are still in secondary school, we have secondary school. Did you use balance in your secondary school? Chemical balance, beam balance. I know that this one is common in secondary school. I can remember this one. I can remember spring what? Balance vividly. I know I used it that time. But what happened is this. The beam balance or this balance has two pans. They call it that. It has what? Just having in mind what happens here. Okay. Now see what happens if you have something like this. You see something like this, and there's a scale here that has a pointer. There's also another pan here. Am I communicating? Yeah. Now this pan, if I'm just having a sketch. Now, this is the right hand side, left what? Hand side, the left hand side pan, and this is the what? The right what? Hand what? Side. Now the basic thing you need to understand, the basic principle behind this is that, in one of the pans, there's what is called standard masses. Standard what? Masses. The basic thing is that you put, let's assume you want to weigh this phone, for example now. What you want to weigh is this phone. Remember I said it operates on a principle of what? Moment. Let's assume you want to weigh this phone. This phone is what you want to weigh. Then you put it on the right hand side. Now, what if you put it will go like this? True of us. Now you now start adding those masses. They have their mass attached written to them. Some maybe 1 kg, some maybe 2 kg, some maybe 5 kg. You keep adding those masses, and as you're adding them, this one is going like this. It's balancing. It's coming up. It's coming up. As you're adding, it's coming up. It's coming up. A time will come, they will be at what? Equilibrium. Right? If they will be at what? Equilibrium. And at that point, the pointer will be what? Good. Now, at that point, now, if you want to know the weight of that the object you want to measure. You calculate the masses you added on the what? On the other pan. Okay? That will give you the weight of that what? Object you want to do what? Measure. Am I communicating? So you keep adjusting. If you add 5 kilograms, it will go like this. You add it will go like this. You do what? You remove it. Add smaller one until they come what? Balance. That is the basic principle behind what? That is any other one you are seeing apart from electronic one. So far it's manual. That is the basic thing. From there is different balances we have triple beam. Many of them. There are many of them, but the basic thing behind it is this principle of what? Moment. Jam ask question like this very well. You just ask you apply question that this is based on the principle of what? I think it's even here. Is it here? See it here, sir. You can answer it here. Instead of number 2. You can answer number 2 here. No. What's the answer? Which of the following statements are true about the spring and chemical balance? A. Both are used to measure mass. Is it true? Is it true? No, it's not true. Either of them may be used to measure the weight of. Is it true? No. 3. The spring balance works on the principle of what? The spring balance works on the principle of what? Hooke's law. Why the chemical balance works on the principle of what? Moments. IV. The change in gravity. A change in gravity changes the degree of the spring balance, but not that of chemical balance. True of us. Change in what? Gravity. Remember, G is not what? Constant, right? Any change can affect it. True of us. So the answer is what? 3 and 4. These are the type of questions you may see from them. They may twist it. So that they will ask you that the weight is measured using what? They will list for you. Beam, chemical balance, spring balance, blah, blah, blah. Just know that weight is what? At this level. If you come up again, you start seeing the different type. There are many of them, but at this level, just take this one at this what? Level. Does it make sense? Does it make sense? Now, so basically, using the beam balance, the object to place is at the left hand. Sorry, is at the left, not right. The object, this is left, right? This is left, right? Following that, this is left, right. So the object you want to measure should be where? Here, not here. Sorry, it should be here. Here. Why? And the standard. And once you drop it here, it will go like this. Moments. You remember that you are doing when you are small. Once you put it here, you do alright. But before you start, ensure that this is at what? Center, remember. So once you put it, it will go up. And if you go up, you don't start adding this. You don't know the mass for now. You keep adding that small masses you have. As you add it will come up. You keep until they become what? And once they are balanced, if you added 1 kg, 2 kg, 3 kg, whatever, here, that's the weight of this. That's the mass of the what? Of what is okay? So that's basically what is involved. Okay, now please, if you are using, look at these precautions. Remember, even though you know that this topic is more practical than theory, to two of us, it's more practical. So you should observe some precautions while handling this. So the precaution you should have is so before we go into that, remember we discussed measurement accuracy. We talked about the accuracy of what? The accuracy or precision of what? We started with meter rule, vernier caliper, micrometer, screw gauge. The same way, you also talk of what? The accuracy of this. In fact, the accuracy of this can be up to 0.001 gram. 0.001 gram. 0.001 gram. When we talk about accuracy, we talked about. No, I will not say it again. Chine, what did we talk about? What did we say about accuracy? Tell us. You are there in the class. Oh, yeah, tell us. Oh, we don't even know what is precision. Oh, yeah, talk to us. Fast. Good. Lowest what? Calibration. Okay. Let's assume now if we have a meter rule that is measured in. Let's assume if you have a meter rule, we have who has a meter rule here? That one you use. Bring it there. Let me. If you look at this meter rule, I'm just refreshing I'm just reviewing what we did so that those that just join us will not be lost. If you look at this thing now, I like this one. Mark, since I will take this thing now. If you look at this thing now, you see this side is in cm, this side is in what? Cm. This side is in inches. So let's work on the one that is in cm. That is the metric system. We are in the world of metric system now. So let's work with metric system. Look at it. If you have 1. Between 1 and 2. Between 1 and 2, the small line there are 10. Okay? 10 divisions. Now what it means is that if you subtract 1 from 2, you have 1 cm. Right? And divide it by 10. That means each of these small this now is 0.1 cm. Are we together? It means that it's what? 0.1 cm. So that shows the accuracy of this what? That lowest graduation on this meter rule, on this rule now. That shows the accuracy. Am I communicating? So and I said something about accuracy and the decimal points, decimal places, and accuracy. I said that the decimal place is what I say about decimal place and accuracy. Fast. You forgotten? Try. Who remember? I will discuss. We said that. I gave an example. I said that if you, let's assume you will now tell me that you say that you use this meter rule now to measure a length, and you got 6.56. It's a lie. It's what? You did not use this thing to measure 6.56. It's not true. Do you know why? The small, 6.56 centimeter is a lie, because the lowest calibration you can see here is what? 0.1 cm. So how did you come off 6.56? How? You can get 6.5. It's correct. I agree with you. You can get 6.6. I agree with you, but not 6.56. It's not possible with this cm. With this, it's not possible with what? This. So we said that we concluded that if you have a measurement, if you measure with a particular instrument, be it meter rule, be it volume, be it spring balance or beam or chemical balance, any one you use and a particular equipment device or instrument to measure, whatever reading you get from that should be in the same decimal places with the what? Accuracy of that what? Of that equipment. Simple. It must be in the same decimal what? Place. With what used in what? Measuring it. So you cannot come from nowhere and tell me. If you do it, I know that you do manipulation. You do physics practical for me, and you tell me that you use meter rule, and you start writing 6.5. I'll just give you 0, because you don't even touch your meter rule. You didn't touch it. It's so clear. Okay, now tell me, how will you read 5.65 from here? 6.56. How? Any question? Okay. But if you have maybe, what do we say about error? What Garikafia? Chinaya. It's only Chinaya that is talking here. What is going on? We did this thing with people. What is going on? I don't like it. And you came at the back, all of you. What are you at the back? In fact, come here. Come on. All of you should come on. Come and sit here. Come, you come. Fill these spaces. Come up here. All of you should come up. Fill these spaces. Fill these spaces. It's only Chinede that I've been talking here, and it's not good. I don't like it. It's not good. So remember, we are talking about this long story started from when I said that the reading accuracy of a beam balance can be up to what? 0. What? 00 what? 1 what? Grams. There are some that are maybe about 0.01 gram. Okay? Good. This thing, what it means is that if you use this weighing balance, this beam balance to measure a particular mass or what have you, you cannot after that and tell me that you got 4.567 grams. It's a lie. If the accuracy is what? 0.101. You can never get this thing. It's not possible. You know, the more, another point I want you to notice this. If you have two devices or instruments that you use to measure the same quantity, like now 2 devices you use to measure beam balances, you use to measure the same mass of your body. The one that has the higher number of decimal places is more sensitive. Okay? If you have, let's assume you have two let's say electronic balance or weighing balance, beam balance or what have you, two maybe you have about 2 or 3, and they have different accuracies. Okay, one may have 0.01 gram, the other one may have 0.0011 gram, so maybe up to 0.0001 gram. Now the one with highest number of decimal places, the one whose accuracy has highest number of what? Decimal places, is the most what? Sensitive. Like now, you may have 2 weighing balances. You may have 2 balances that have accuracies. Something like this. They have accuracies. They have accuracies 0.01 gram. Okay? And one has 0.001 gram. This one is more sensitive than what? This one. Do you know why? You can use this one to measure 4.565 gram perfectly, but you cannot try it here. This can only measure 4.56 gram. What of this 0.5? Is something. True of us, this cannot measure it. So this one is more what? Sensitive than this one. There are some weights you get. You cannot use this one to measure. You use what? This one. That's the meaning. Okay, now if you want to measure length, there are some length you want to measure. You cannot use meter rule to measure it. You can start using what? Micrometer, screw gauge. In fact, there are some vernier caliper cannot measure because vernier caliper has accuracy of what? Tell me. 0. What? 0.1 what? In cm first. In cm, 0. What? Meter rule is what? 0.1 what? cm. Vernier caliper is what? 0.0 what? 1 cm. Micrometer screw gauge is what? 0.001 cm. Have you seen it now? Does it make sense? So this thing, there are some things there are some things you cannot use this thing to measure. You start looking for what? Vernier caliper. There are some you cannot measure with vernier caliper. You start looking for what? Micrometer what? Screw gauge. Okay. Now that is what's basically the relationship between the accuracy, precision of an instrument and the what, and the decimal what places, and the implication. Anybody that knows measurement very well, you stay in the lab and say that you report that I measure, I use you just look at accurate, you just look at you are reading. So far it's not a calculated stuff. It's what you measured with an instrument. It's not possible that the decimal place of what you reported will be more than the decimal place of the what? The accuracy. You did not even touch it. In fact, you don't even see where the instrument is. Was. You didn't touch it. You didn't even go close to the instrument. That's the meaning. Alright, so now that's about what? The accuracy. I wanted to say something before going into that. Now, there's something I want to let you know. Please, if you are, the masses that masses, remember the object you want to weigh is here, right? Right? Is here, left. Now, these masses you are putting here, don't just use your hand, your bare hand to do what? Pick it. It's a precaution. Don't use your bare hand to do what? Pick it. It may introduce a lot of things that may even alter the weight. Okay? Most of these things are very, very sensitive. Don't use your hand to do what? Don't use it. Instead, use what? Clean, dry what? Forceps. Okay? Use forceps to pick the masses you want to be dropping on this right hand side. Even the object you put, you don't just be careful about it, because most of these are very sensitive. Look at it, they can be up to sensitive of 0.01. Any slight, it may be dust or anything, it will read. Okay? So you should be very, very careful in doing that. So use forceps, not bare hand, to pick the masses, standard masses. Of course, now the object you want to measure, you should wipe it. Make sure that you wipe it clean, so that there will be no atom of anything, any deposit of anything on the watch, the watch you want to, because any deposit on it will affect the watch reading. True of us, it will affect reading. Maybe if there's any deposit on that mass object you want to, we see what will happen. Maybe you put it here, you'll be adding weight at the end. The weight you measure, the mass you measure, you get. Your reading will now be the reading of the object and the reading of that thing that deposited on the two of us, and it will give you a false reading. Which, if you are working in a very sensitive environment, maybe there are some discipline like those in pharmacy. If you have, what is it? I heard, I don't understand. Who said that? Okay, please, if you don't understand, ask questions. Okay. Now, if you're not careful, that there will be some deposit of anything on the body, and it will contribute to the what? The reading you get. You will think that is the mass of that body, without knowing that it's the mass of the body plus the what deposited on it. And if you are working in there are some profession that like those compounding drugs, those in pharmacy, those that study pharmacy, where they prepare drug. You see that small 0.00 gram can make or mar, depending on the nature of the drug they are compounding. So you should be very careful while handling these things. That's the point. I'm just linking it to real scenario so that you appreciate the importance of taking these precautions. Not just about this thing you do in your physics lab. It It goes beyond what? That, okay? Now, another precaution you need to take is that please do not weigh a hot what? Any object that is hot, don't weigh such. Allow it to do what? Cool. Remember, allow the object to do what? Cool. If an object is hot and when it's cool, and we have some expansion, three of us,
Yes.
and other things involved. So I just allow it to cool, okay? Cool. Then before you now do what? Continue your what? Measurement. Are you with us? Aneke, you are lost. What is it? What happened?
Okay.
No, it's not true. What happened to you?
I'm having a
You, no wonder. I know what my student is lost. You are lost in contemplation. Even you, Cynthia, Aloma. Please, if you are lost, come back home. Let's welcome them back home. Please come back home. Huh? Which one? The third one or all of them? Okay, I start from the beginning. Okay. see. Sorry, I didn't start. See. Please, in my lectures, in my lecture, as I'm talking, you're doing what? If you're not good at that, record, okay? If you're not very good at that, everyone must not be secretary. If you're not good at that, do what? Record, no problem. If you record, make sure that you position your phone in a place that you can record the voice well. It will be clear. Then if you don't know how to write, you don't know how to record, don't worry. I'm recording. I'll put the link for you. You spend your data and go and do what? Listen to it. So either way, you must get it if you want to. Okay? So as I'm speaking, just be. I don't know what is calling me. I don't know what it is. But I believe that if I teach you that, you know it. If you know it, you can throw your pen anytime and do what? Put it in different ways you want. Okay? So you say I should say, okay, where this stuff? Let me. What did you even write in the first place?
Just this one that you said that I do not weigh any thoughts.
Okay, the first one I said that do not pick the masses, right? The standard masses with what? Bare what? Hand. True or false?
Yeah.
Good.
Should be picked with your forceps.
Use what? Clean forceps. Then another one is that the next one is that you should do what? Good. The object you want to make sure you clean it well. To avoid what? Because some there may be some deposits. Maybe from where they kept the object. You may be looking at it, you won't even know that there are some particles on it that are not even the object is a true or false, and they contribute to what the reading you will get. And you'll be thinking that I gave instances, real life scenario where you are working in a drug manufacturing company, or you are using a very sensitive balance. Be careful. If you're not careful, introduce that some things that are not even what you are weighing, you won't even know. And at the end, you start producing what will kill instead of what cure. Does it make sense? Now, are you okay now? Good. Any question? Oh, 6 o'clock. No, we'll finish this thing before we go to the first time. I want us to look into time in our next class. So let me see if there's any other thing I'm missing. Of course, I've given you some precautions in this spring balance, right? I said don't hold it with your what? No, I mean spring balance. Hang it, right? Yes, good. Please. Very important. And as you are reading, listen carefully. For a spring balance, because it's hanging, right? It's hanging like this. Maybe you are hanging on a support like this. As you are reading Okay, it has cleaned. Remember, error due to what? Pararas, right? We did this in this class. Error due to what? We also defined error due to pararas. Where them? We defined it, right? Please, you push, not deny me. Now, look at this spring balance here. Now, as you are reading this thing, as you are reading it, please ensure that your eye is at horizontal to the what? Pointer. Okay? The same horizontal. Don't look like this. Don't look it like this. Your eye should what? To the pointer. Okay? So you can avoid error due to what? Pararas. So you can avoid error due to what? Pararas. Very important. Hang it. Don't hold the spring balance with the hand. Hang it so you don't misread. And as you are reading it, please ensure that your eye is horizontal to the what? This thing. Okay? Now, next thing that when you are working with the spring balance, please, before you even put what you want to, the weight you want to check, please draw it first. Draw it. Allow it to release, okay? Draw it. Because if you know, spring can be funny. Three of us ensure that there's no what? Come well. Hey, choose the woman that does not come well. Anyway, come well is also there. Hey, check it well. But you should clean it. Very important. Okay? Clean it. It doesn't matter. Clean it. Have you seen cowboy before? See a big car. Have you seen cowboy before? Anyway, it depends on how long you kept this. No, I'm trying to put that he's not totally what? Wrong. It's part of maintaining the what? The spring, okay? Depending on how long you use it. In as much as it's sounding funny, but at least it's not totally what? Out of what? Okay. Now, I think at this level we've done justice to weight and mass. And believe you me, if you were putting down things I've been saying here since, maybe about 2 pages of your note will be filled up. Putting down what I've been saying for the past 45 minutes, 3 of us. I've seen a lot of things here. Some are not, some are just there looking at me. And lectures. The lecture is going on. Look at Chine, see her notes. It's filled up already. Alright, please, in our next class, we'll look at time. I think after time, at least we'll say bye-bye to unit and measurement. We've done dimensions, right? These dimensions, we started with dimension. Our last topic, in our next class, we conclude measurement and unit. We will do time. We can even finish time now. It's not even much. No, let's stop. I don't want to keep you here beyond 6. We just finish it and enter the next topic in our next class. Now this topic we started with unit quantities and their units, because it's not if you know a unit you're measuring that you measure it. 3 of us. So we started with the quantities, their units, those that are derived, those that are fundamental. And we look at dimensions of the derived quantities, and we solved a lot of questions on there. Then we now came down to actual measurements. We started with length, volume, now it's weight, mass. Next one is what? Time. Then of course you know temperature now, even though it's not in the syllables, but it's good you know it. So after that, we now enter the next topic. So I think our next topic should be, we go over to scalar and vector quantity. Wait. Sorry. We go over to We go over to okay. We can do it together. We go to displacement, how to use. You see what displacement in another dimension. I think there's a question we solved here some time ago. You start checking the bearing, direction, right? Direction and the that is what displacement is all about. We do it position, distance, position, displacement. We treat them then vector and scalar quantity. But that will be when we are done with the time. Any question? Ask question. If you don't have any question, I'll ask you. Zero. Okay, as a precaution. Yes, I think I mentioned it here, right? I mentioned it here. Did I? When I say that I ensure that this thing is what? Is it because I don't dictate. Avoid zero error. See. On a more serious note, sometimes if I say this, people think that maybe sometimes the way some things are presented when you are coming up will make you to just carry it in your head like that without even taking out of the box. I said avoid. I make sure that before you start, ensure that you what is at the what center, which is what zero. True of us. That is zero error, and it's a precaution you should also do what take. Maybe I didn't present it. I didn't present it in the. But sometimes even that one they were saying that time they just say it. Some people don't even know the meaning of that zero error. True of us.
Because after they will tell us the same thing, after that zero error, they will still tell us that we should make sure that it has the same time.
It's okay. What is give snapping? All right, okay now. What is the SI unit of weight? Don't look at them. Don't try it. Don't even go there. Answer. What is the SI unit of weight? Is what? You don't know. Cynthia. Newton. Okay. Newton. Can you give me one difference between mass and weight? Just one. Be looking at me. Don't look at anything. Just look at me. I will before I answer that question. Don't look at anything. Don't try it. Oh yeah. Mass is what? Okay. Force of attraction on the body or the pull on the body. Okay. Oguzie, Sorry, man. Answer. No, Oguzie. Another difference between weight and mass. No triumph. No triumph. No triumph. I answer. Muchia go na Azamia. Don't look at anything. Answer me. Give me one difference between weight and mass. It be na be na ya. Ozagonia now. Please, I want you to always see. See. There's something I want you to always do. In a class, you may not 100% have everything still in the class, 100% in your head. But try. Make it a point of duty that in any class you attend, even as the lecturer is teaching, try to assimilate up to 60%, even before you go to read the topic. It's very important. And how will you do it? Maximum what? Attention and critical thinking. As the lecturer is teaching, be reasoning whatever he says. Not just sit down and looking for what to copy Try to be reasoning what is. Be watching the lecturer's line of thoughts. Try to have a critical analysis of whatever the lecturer is saying. Don't just sit down. Because if you just say like this, next you start sleeping. Next your mind will go to Ochanja. Kaduna. If your house is in Kaduna, your mind will just be go to different countries, but they're still down here. It's because that maximum concentration area, you are distracted. The first task you give yourself is that I will make sure that at least 60% of whatever lecturer is saying, if you ask me that question, I can start up and answer it. And the only time you can achieve that is to put all your attention there. It's simple. You don't have to cram it. Just try to understand. And at a point when you are beginning to lose it, don't give up. Because some of us switch off. We call it what? Switch off. Maybe you are flowing at a point. You begin to know. Maybe it is lecturer say something you don't understand. You just switch off. And once you switch off, you will never understand anything again. Once you notice that you are taking towards that direction, ask question. Ask question. Ask question. And sometimes, if you ask that question, the lecturer may even flow back to your line of thought because you ask what? Question. So please, it's very important to put your attention in. At least, even 40%, you can now sit down, you open your book to read, and you now understand probably what the topic is what. All right, thank you very much for your attention today, and God bless you. See you tomorrow.